Hey there, everyone. Welcome to Math 44. This is mathematics for liberal arts majors. It is got the fundamentals of beginning and intermediate algebra in it. All you really need for this class is a good notebook. I have my notes right here. Just a simple composition rule. The graph one is better because you're going to be doing graphs. You should be able to get it all in one of these notebooks. But if you need something bigger, go with something bigger. Just a basic standard calculator. It's a scientific calculator. It's not nothing fancy. It doesn't graph, doesn't store anything in memory. But you don't need it. If you practice this stuff and get decent at it, you don't need it. We will be using John Blakely's free textbook, but the homework software is not free yet. I'll cover that in the welcome video. John Blakely's textbook is at johnblakely.com/textbook. If you just go to johnblakely.com, it takes you to his homepage, and you can click textbook here. He's another instructor here. He was my instructor when I was a student here, and I learned a lot from him, and he's got a good textbook. We'll be using that. We'll be going from chapters 1, the basics, all the way up through chapter 8. Okay, that's what we're doing. Let's hop into it. So the first section I'm doing, if you take a look at the list, is stuff on integers. And if you like reading textbook and stuff like that, please feel free to do so. It's all PDF, it's all easy to access. We're going to be going over a bunch of this stuff right now, practicing some operations. So 1.1 is on integers. Integers are whole numbers, zeros, and the negative numbers. Just they got to be a whole number though, no decimal places, anything like that. So like we have 1, 2, 3, 4, and we keep going up. We can include 0, or we can go negative, like owing money. And they count away from 0 the same way. So 3 from 0 that way is 3 this way, and the numbers look the same, just a negative sign. In fact, that's where we have that number line that we like to do. 0's in the middle. And we can go right and stuff like that. Hopefully a lot of this is review for you, at least in the beginning, because we're going over a lot of basic arithmetic and stuff like that. All right, so inequality symbols. We have four inequality symbols. We have less than. If we add the bottom line to it like that, it's less than or equal to. I could have greater than, or greater than or equal to. And just to make it really clear so people aren't making a mistake, people mix these symbols up all the time. That reads 2 is less than 5. That is 4 is greater than 1. If you treat it like an alligator or a vampire, it's going after the bigger meal. Okay. So on the number line, we can see 4 is greater than 1, or 1 is less than 4. Numbers to the left are less, and numbers to the right are greater. So we'd also have -4 is less than -1. Even though the whole number portion looks bigger, the negative sign makes it go the other way. All right. You have your basic addition, subtraction, multiplication, division. Since you can use a calculator, I'm not going to write everything out by hand, but it is worth illustrating some ideas that might stump students with the negative numbers. If you're adding negative numbers, this is like subtracting the positive number. So I have 5 plus -2. This is the same thing as 5 minus 2. And I hope you don't need a calculator for that. If you grab a calculator for everything that's basic math, you're going to be forever slow, and you don't want that. Test, you're on a limited timeline, and let's be honest, you can use this stuff in grocery stores to track how much money you're spending, stuff like that. You don't want to go over your budget. No one likes getting the cash register broke or looking broke, even though you know you had $50 in the account, but you have $52 in your basket. So you can count the stuff as you're going. Adding a negative is the same thing as subtracting a positive. Subtracting a negative is like adding the positive. So the negative sign does the good old switcheroo. 5 minus -2 is the same thing as 5 plus 2, which is 7. And some people like to do this, just draw lines through the minus signs. If you do it in a calculator, do I have a negative key on here? I have a minus key. 5 minus -2. Does that work? Yep. So I got a worker. You just got to make sure you do it. Generally, you want to use parentheses. I had 5 minus -2. Or if you're writing it out, you want to elevate one of them a little bit higher than the other. If you're not going to use parentheses, you should use parentheses. This avoids mistaking the negative as part of the minus sign. Multiplication, I hope you know about. It's really just repeated addition. So anything that works for addition, it works for multiplying. And so if I want 5 times 2, 10. Division is, let's do division on another page. Pause this as you need to take notes. I'm going to try to do these all in short 10 to 15-minute videos. There might be a bunch for each section, but they'll at least be bite-sized. 1.1 is relatively quick. Division is really just repeated subtraction. And we have a couple symbols for that. 7 divided by 2, or 7 dash 2, or as we're going to see in 1.2, the next section we're doing, fractions are division. 7 divided by 2, 3.5. Some important things to note under multiplication. Any value times 1 is just the original value. Like 7 times 1 is 7. Any value times 0 is 0. Hopefully you guys know that. 1 billion times 0. And pretty soon, we're going to start working with variables where x is a variable. So another way that we show multiplication is with a dot. And it's elevated, so it doesn't look like a decimal place or decimal point. So you know the odd numbers are 1, 3, 5, 7, 9, dot, dot, dot. Numbers not divisible by 2. Not evenly divisible by 2. And even 0 tends to go in that category. Divisible by 2. And also the negative versions of these. When we're multiplying, two positives make a positive, we saw up above. If I multiply 7 times -1, I get -7. And if I multiply -3 times -2, I get +6. So for multiplying and dividing, count the negative signs. If it's odd, the result is negative. If it's even, the result is positive. And one final thing I want to slip in regarding division. I haven't touched on the negative numbers. The division sign has the same thing. If I have 9 divided by -4, I can write this as 9 over -4. Or I can put the negative on top with the 9. Or I can put the negative out front. These are the most common ways of seeing it. Leaving the negative on the body is like a noob move. Don't be a noob. You cannot divide by 0. I try to put little horizontal bar through my z's so they don't look like 2's. 16 divided by 0 is undefined. And it has to do with that repeated subtraction thing. 8 divided by 2 is how many times can I subtract 2 until I'm down to 0? If I keep subtracting 2, I can only subtract 2 4 times. And so 8 divided by 2 is 4. 16, I can keep subtracting 0 and it never goes down. So it's called undefined. What else do I want to tell you about? Oh, other things with division, just like we had these fun rules up here with 1 and 0. I just showed the 0, 1. If we have a value divided by itself, we get 1. So like 5 divided by 5 equals 1. This is a fraction kind of idea. One thing you can do for mixed numbers, if you see mixed numbers like 2 and 3/4, this means 2 plus 3/4. And we're going to do fractions in just a second and go through all of what they are. You hopefully have seen them by now. And we'll show switching fractions to mixed numbers in 1.2. There's one other topic I almost didn't tell you. Absolute value. The absolute value is the distance of a value from 0. And we do absolute value with big bars like. So the absolute value of -3 is 1, 2, 3 away from 0. So it equals 3. The absolute value of +3 is also 3. Now, this is going to be handy to remember later on. The distance thing is going to be pretty important later on to remember. For now, if there's no operations inside of the absolute value, make it positive. What I mean by that is if I have -5 plus 2, the wrong way is to just make them positive right now, and I would get absolute value of 7, which is 7. The correct way, add them up first. Then make it positive. If you want to do this step quicker without a calculator, and the bigger number is one's negative and one's positive, and you're adding them together, subtract smaller from bigger. And use the sign of the bigger number. So -5 plus 2. I'm going to do 5 minus 2. And since 5 is bigger, I'm going to do the negative sign on the outside. -3. If it's not the bigger one, I can actually rearrange this. Addition switches orders. And that's 10 minus 3, which is 7. I tend to put bars on the 7s when I remember, so that way it doesn't look like a 1. And that's kind of it for 1.1. Be back shortly.